John,
Good evening, everyone. My name is John
pull that real close and speak loud.
Good evening, everyone. My name is John Honore. I'm a section chief with the Texas Division of Emergency Management, and I am the agency's chief meteorologist. I've been an operational meteorologist for 31 years, an overwhelming majority of that in various regions of Texas. And I've been with TDEM for a little over 8 years. I've been asked to speak on a couple of topics today, so I'll speak about those now. One of the things I was asked to talk about is how meteorological data is collected, analyzed, and used for disaster planning by TDEM and our partners. Most of that data is collected by the National Weather Service, as well as the Weather Service's parent agency, NOAA. That includes satellite data, radar data, weather balloon data, surface observations, and other types of remote sensing. That data is then taken and put into different computer models that are generated by not only NOAA, but private companies, foreign weather services, and other entities. I take those forecast models and my team analyzes that scientifically, as well as analyzes it based off of our experience to help inform the agency's operational posture. As far as how that is used, I'd like to refer you to Chief Kidd's testimony last week and how he uses that information for his decision making. But the big picture is this. We didn't have any access to any exclusive information. My team we're there to inform TDEM's operational decisions based on public information provided by the Weather Service, as well as that weather information that comes in from the Weather Service. Our team's extensive experience and understanding of Texas weather and the history of Texas weather is what leads us to make some of those operational recommendations to TDEM leadership on deployment timelines to best support our locals ahead of potential storm impacts. While our field teams are often and regularly communicate these forward-leaning operations and work with our local partners to ensure proper coordination, we also provide updates on these tactical decisions on a 10 a.m. statewide weather call, which is hosted by TDEM, featuring a National Weather Service briefing, updates from the Texas Emergency Management Council members, and other partners. With regard to conditions leading up to the 4th of July, for several weeks this summer, we had a persistent onshore flow at all levels of the atmosphere, from across the Atlantic Ocean, through the Caribbean, into the Gulf, and into Texas. It was pointed right at us. It made for, even by Texas standards, unusually humid conditions. So we had a moisture-rich environment. Then the weekend before, leading up, or actually 3 weeks before, pardon me, that's been mentioned before, we had a serious flash flood event in the San Antonio metro area. Parts of Medina, Bexar, Comal counties had areas of 5 to 9 inches of rain. We saw that given a lot of the weather data, the potential for that type of flooding. There was no way to pinpoint exactly where that flooding would be. The atmosphere was very, very wishy-washy. It's very difficult for the computer modeling to get a handle on exactly where that heavy rain is going to set up. But the conditions were out there for something like that to happen. And sure enough, we had a serious flash flood event in San Antonio, and that put us on even more vigilant stance going into the upcoming weeks. So the weekend before the 4th of July, we had Tropical Storm Barry make its way on shore into Mexico, traveled through northern Mexico, kind of dissipated, but its remnants moved through West Texas and eventually started to work its way into central Texas. At that point, some of the computer modeling started to pick up on the heavy rain threat. That in and of itself, just the fact that we've got a weak disturbance floating around slowly in a very humid environment is going to set off red flags. It's even been mentioned here on this panel. Also mentioned was Harvey, Imelda, Allison, all slow-moving storms. The difference with this, though, is that it wasn't a named, organized storm with a well-defined center that the computer models could really latch onto and understand where it was going to go and how much rain it was going to drop in specific locations. We didn't. This system was much more analogous to the flood of 2002, where you had just a very weak disturbance floating around the hill country, tapping into a very humid atmosphere and dumping a tremendous amount of rain. The problem is we've seen that before, after 2002, didn't generate this type of rain. So going into the fourth, in the days coming into the fourth, there was computer modeling showing extremely heavy amounts of rain, but it was not consistent as to how much or where it was going to fall. But given our experience and our knowledge of Texas history, it gave us cause for concern to inform our leadership and our partners that there was concern that there was a serious flash flood risk going into the 4th of July weekend. So that's basically what the setup was going into that storm that occurred over the 4th of July weekend. And I just wanted to say we remained committed to working with our local partners and stakeholders to ensure communities have the resources they need before, during, and after a disaster. And I thank you for your time.
So I'm going to violate my rule because I can, our rule. Real quick, really what I wanted to hone in on, because there was a lot of confusion last week, and rightfully so, we're not weather people, as to who's got data, who uses data, what they use the data, and where does the data come from. So specifically, and I'm going to share from my understanding, correct me if I'm wrong, and I've got another 6 opportunities are here to correct me for sure. NOAA is the keeper of all inputs that generates the models that you take and every meteorologist around the country takes.
An overwhelming majority of it, yes.
And so NOAA is getting feeds from gauges, USGS gauges, we've talked to those ad nauseum, local sources, private sector sources, Mezanets. Texas has large Mezanet networks, both at Texas Water Development Board, and then private sector. And even, I think I heard a different one today, LCRA may have their own.
Correct.
So all of that is pushing data up as inputs, no modeling, just they push that raw input. They put it in their system and they generate what they believe is a forecast, and that's what your 10 o'clock calls are based on. That's what your internal conversations are centered around. Is that basically the correct understanding?
Sir, I'm not fully up to speed on everything that the Weather Service puts together to come up with their forecast, so I wouldn't want to, it would be irresponsible for me to definitively say, yeah, that's what.
Sure, but in general, we have more data gatherers than we have more predictors. We leave the predictions up from kind of coming out of NOAA down to National Weather Service, and then the local guys kind of get to add their flavor to it, I guess. Is that kind of a general statement?
You're saying that when you say the local guys,
there's local input once it gets kind of out of.
So you're referring to the Weather Service,
right?
Again,
Okay.
I don't think I'd be very responsible for me to comment.
We'll go to the next the panel. We'll try to get through them, members. I just wanted to set effectively what we needed to know is who's sending data, who's using the data, what it's for, and then we get into the whole modeling conversation in this panel too, which is kind of where all the magic happens. You know, all this stuff comes together and people put it together and come up with what they think is right. So let's move on down it. I just want to kind of set that stage because we're going to hear, if you're going to say the same thing that we just agreed to, you can skip that part of your 10 minutes. All right? Thank you.
Good evening, Chairman Perry, Chairman King, Vice Chairs, and members of both the Senate and House Select Committees. My name is Carla Guthrie, Surface Water Division Director for the Texas Water Development Board. Thank you for the opportunity to describe our Tex Mezanet statewide weather network that we're working to build for Texas, and to answer any questions that you may have. Although floods are a part of the Texas landscape, the events that occurred this past month are particularly tragic and I offer my heartfelt condolences to everyone who is affected. Today, I will provide a general overview of the Mezanet system operated by the Texas Water Development Board, a description of its utility for natural disaster-related planning and response, and recommendations for improving Tex Mezanet for this purpose. I will address each of these topics and welcome questions to fill in the gaps. You also have a presentation in front of you that will be helpful for understanding what I'll present. So next slide, please. The Tex Mezanet is a statewide hydrometeorological observation network that's operated by the Texas Water Development Board. It is designed to collect and distribute high-quality, near real-time atmospheric and soil moisture data across Texas. The network supports water resources management, drought and flood monitoring, emergency response, agriculture, scientific research, and more. Specific to natural disasters, the initial stations in the network were installed to provide better data for warning and forecasting of flood events following the Memorial Day Wimberley flood. However, station data also is informative for droughts, heat waves, tornadoes, fire, wind, winter storms, and tropical systems and hurricanes. In 2023, the 88th Texas Legislature authorized the TWDB to serve as the statewide resource for hydrometeorological data as described in Texas Water Code 16.026. However, the first Tex Mezanet stations began reporting in 2016. And today we have 118 stations reporting across Texas, and we're continuing to build this network out to at least 225 TWDB-owned stations to fill in gaps in coverage. The map on your slide shows TWDB-owned stations in orange, and the gray triangles show all other locations where we have partner networks that have similar weather station information. The counties shaded in gray reflect those most impacted by the recent floods. Next slide, please. Each Tex Mezanet station collects a suite of parameters, including temperature, precipitation, and soil moisture. The data we provide is available for use as needed by others, both during disaster and in clear weather periods. In a few slides, I'll go over how we make the data publicly accessible. But I also wanted to show on this slide the Mezanet coverage in Kerr and surrounding counties. There are 2 stations within Kerr County, a station at the Kerr Wildlife Management Area and another at the Kerrville Municipal Airport. However, there are other stations just outside of the county that also provide coverage. And so if you look at the slide, you can see a series of orange circles and gray circles. Those circles represent the coverage around a station. And so we're building out the network so that there is at least a 20-mile buffer or between stations. So around each station, there's a 10-mile radius. So when you look at that, you can see that there's fairly good coverage for Mezanet stations in Kerr County. This also is not showing the GBRA rain gauge stations, which also provide coverage. So while there are gaps, there is a reasonable amount of coverage, and I wanted to point that out to you today. Next slide, please. Much like the National Mezanet program, of which Tex Mezanet is a member, we have designed our program to operate as a network of networks. We rely heavily on partnerships as well as our own stations. Texas is large, and by working with existing Mezanets and state partners, we are better able to provide a cost-effective means for ensuring broad coverage. Through our partnerships, such as with West Texas Mezanet, who covers West Texas and the Panhandle, and other entities, as listed on the table on the right, we are able to display data from over 3,500 cooperator-owned stations on texmezanet.org. With respect to the collaborative nature of our program, we rely on the Tex Mezanet Advisory Committee to guide our program on data collection and dissemination methods and on product development. We have 2 of our committee members here on the panel today. Dr. John Nielsen Gammons serves as our chair, and Dr. John Schrader is representing West Texas Mezanet. We also have representatives from the National Weather Service, Regional Weather Networks, Oklahoma Mezanet Program, state agencies, and members with expertise in a variety of subjects. Tex Mezanet also contracts with several universities to improve data products, data quality, station coverage, education, and outreach. However, one important point that I want to make today is that Tex Mezanet relies on landowners to provide space to host stations. We have agreements with Texas Parks and Wildlife Department, other state and local entities, as well as with private landowners. And this is one of our greatest limitations to expanding the number of stations in areas that lack coverage. We need to find landowner hosts who are willing to provide the space and access for a station, and we welcome those who have the space and are willing to partner with us to help us continue to expand the network. Next slide, please. TWDB stations collect and report out all measurements every 5 minutes. However, many stations in our partner network collect and report at different frequencies. There's not a standard across all networks. And remember that each network is designed for a different purpose, and not all need to report at a 5-minute rate all of the time for all parameters. The pie chart that is shown on the left slide shows the proportion of stations in Texas that are collecting data at various frequencies. From our assessment, a majority of stations, the color shown in blue, so 39%, collect data between 5 and 15 minutes. But only 23% of stations are collecting data at a frequency of 5 minutes or less. And so in terms of the frequency of reporting data, most networks are not reporting at a fast rate. The American Association of State Climatologists recommends a 5-minute collection and reporting rate, and this is the rate at which our stations adhere to. And there are only 2 networks in Texas, Tex Mezanet and West Texas Mezanet, that meet this 5-minute data collection and reporting requirement for stations. And these locations are shown on the map that's on your right. And so you can see much of the state lacks stations that are reporting at a high enough frequency to be informative during intense rain events. Next slide, please. On this slide, we wanted to show why it's important to have 5-minute rain data. You can see here a graph for rain gauge data at the Kerr Wildlife Management Area. It's within the watershed of the North Fork of the Guadalupe River. In this graph, the orange line represents data at 5-minute intervals, and the gray line represents a 1-hour reporting interval. If I can draw your attention to the yellow highlighted area, between 3 a.m. and 4 a.m., we can see how receiving information in 5-minute intervals allows for quicker decision making. And I want to note here that at 3 a.m., we already had 2 inches of rainfall in the watershed, and we were about to receive 3 more inches. So having a 5-minute data reporting rate is extremely important for monitoring intense rain events such as this, where rain fell at a rate of 1/2 inch every 10 minutes for that period of time. And so we would encourage a 5-minute rate of reporting for all partner networks if the National Weather Service and emergency responders agree that it would be meaningfully helpful during such events. Next slide, please. I want to close by describing the 2 ways in which we access our data. Our data is accessible. First, TWDB station data is delivered from our stations to our cloud server via AT&T's FirstNet communication platform, and then it goes to our online web viewer at texmezanet.org. The viewer is the most common way to interact with the data. It contains TWDB station data, which is pulled from our cloud server. It also contains active radar precipitation visuals and data from over 3,500 stations within and surrounding Texas. For the viewer, we also pull data from non-TWDB stations. So we pull that from Synoptic and from West Texas Mezanet. The main landing page is available in Spanish and English, and additional pages provide precipitation and temperature maps and allow for limited data downloads. During the July 2025 flood event, Tex Mezanet stations were reporting near real-time data, and the viewer remained operational throughout the event. Users of the viewer include the National Weather Service Hydrologic Service coordinators who've used this viewer at the State Operations Center and as part of their briefing notices. Other users include educators, news meteorologists, general public, emergency responders, farmers, and more. Next slide, please. The second way to access our data is through Synoptic, who pulls our data from our servers into their database. Once the data goes to Synoptic, it is available to be downloaded for use by anyone for whatever purpose they need. Synoptic houses TWDB data, partner data, and data from other public and private entities. And within Synoptic, the National Weather Service is able to use the Meteorological Assimilation Data Ingest System, MEDIS, to access this data. And so to recap, we have 2 ways in which this data is available for events such as this. Our data viewer, which is helpful during an actual event to see the event as it unfolds, and then via Synoptic, where raw data can be downloaded for scientific analysis or use in modeling. And so this concludes a high-level overview of the Tex Mezanet program at the Texas Water Development Board. I thank you to the committees for your interest and attention in our program. We are also appreciative of the support this program has and continues to receive from the legislature. We believe Tex Mezanet offers great value to Texans, and we welcome all suggestions
Thank you very much.
make this program more beneficial.
Thank you very much for that. We'll be back to you shortly. Please proceed. Just state your name and tell us what you're here for.
Thank you. My name is John Nielsen Gammon, College Station, Texas. I'm the Texas State climatologist, professor of atmospheric sciences at Texas A&M University, and the director of the Southern Regional Climate Center. Chairman Perry, Chairman King, and committee members, let me say at the outset I hold deep sorrow for the victims of the Hill Country floods this month, their families and friends, and everyone else who's been touched by this disaster. In the interest of time, I'm going to hit the key points of my written testimony here. I was appointed the Texas State climatologist by Governor Rick Perry in the year 2000. The mission of the office is to help the state of Texas make the best possible use of weather and climate information. The Office of the State Climatologist, or OSC, has no statutory responsibilities for disaster planning and response. Indeed, there is no enabling legislation for the OSC. The office was created at Texas A&M by Governor Briscoe in 1973 in response to a pullback from NOAA, from state-level climate services. We receive no direct baseline funding through the state budget. Our operating budget is provided by Texas A&M University. We also receive occasional funding from state agencies for particular projects. Given my own scientific background and experiences, I've made the focus of the office extreme weather in Texas, particularly droughts and floods. Much of this research and service is directed toward understanding extreme rainfall risks, which in turn can inform planning and preparedness activities. In my testimony, I highlight a few examples, and I provided a more detailed list as an addendum to this testimony. In 2005, we analyzed every rainfall event in Texas from 1948 to 2002 that produced at least 20 inches of rain. There were quite a few such events. We also looked at computer simulations with rainfall in one particular event that happened to be the July 2002 event that Jean Honoré just mentioned. We found that for events like this, it was not possible to predict the locations of extreme rainfall at the county level a day or two in advance with computer models, no matter how good the data is. I also work directly with state and local agencies when requested, such as TDEM, ERCOT, the PUC, the Railroad Commission, and TCEQ, and TWGB. For Harris County Flood Control District, we look specifically at the new numbers from NOAA Atlas 14, which is the document that lays out how much rainfall you expect in a 100-year event, and considered whether those numbers were too high for southeast Texas because of Hurricane Harvey skewing the statistics, or alternatively, whether they were too low because of climate change. We concluded it was some of both. The 100-year amounts are probably overestimates for the present-day climate, but in 3 or 4 decades, the climate will catch up. We later broadened our study to look at all the south and southeast United States and found that overall the amount of rainfall with a 1% chance in any given year has increased by about 15% over the past several decades. What particularly concerns me are the implications for all the places outside of southeast Texas, like Kerr County, that didn't get a Harvey bump in their statistics. For them, the official 1% annual rainfall numbers and floodplain extents are likely already too small because they assume there's been no trend in extreme rainfall. There are things going on right now that try to fix the problem. NOAA has work in progress, for example, due to their own study mandated by Congress. But the TWB has contracted with me to develop new extreme rainfall return values for Texas that take historic trends into account. I brought in colleagues from A&M and from Rice University to help on the project. We're testing out some strategies we think will produce more reliable numbers than what NOAA will be coming up with. We're in the final stages of that study now, and we expect the results to be available sometime in the fall. Now I wish to talk specifically about the Hill Country floods and some recommendations regarding them. This being Texas, there are plenty of past floods in this very river basin that in different parts of the basin rivaled or exceeded what happened on July 4th at or upstream of Comfort. July 1869, September 1915, July 1932, August 1978, and July 1987. More broadly, various historic precipitation totals in the hill country are sobering, keeping in mind that the Guadalupe River flood was caused by 10 to 15 inches of rain, and the floods near Mason County and Leander were produced by about 20 inches. September 1921, east of Austin, 36 inches of rain in 18 hours, a United States record at the time. July 1932, Mountain Home, about 20 miles upstream, 19.6 inches in 6 hours, over 33 inches in 24 hours. May 1935, north of Dehanis, 21.8 inches in less than 3 hours. June 1948, Sycamore Creek, 36 inches total. June 1954, Pandale, 35 inch total. August 1978, between Hunt and Medina, over 48 inch total rainfall over 2+ days. Based on a simple count of these events, we should expect a 35-inch rainstorm, which would be well over a 1,000-year event, somewhere in the area, on average, every 2 decades. Now, that doesn't seem possible if it's a 1,000-year event, but keep in mind, it's a 1,000-year event at any given particular location, and every individual location has its own odds. Regarding weather warnings, getting warnings is one thing from the Weather Service. Determining the proper action is another. Sometime in the middle of the night, the situation changed from there's a flash flood, appropriate action is to stay indoors and not drive, to there's a flash flood, appropriate action is to seek higher ground if you're less than 20 feet above the river, or then less than 25 feet, or less than 30, or possibly less than 50, as the situation evolved. And the weather warnings did not keep pace with that threat and with the change in action necessary. But during the past 23 years, there's been 111 flash flood or flood warnings issued by the National Weather Service specifically for Hunt, Texas. It's critical that any future warning system clearly identify the appropriate action to take, and that action needs to have a reasonable probability of actually being necessary under the circumstances, or people will again start ignoring the warnings. And furthermore, that action to be supplemented by education on which places are at risk and what to do, how to evacuate any given location. Regarding better data and models, I'll focus on models of the atmosphere that predict precipitation. The Weather Service runs several models, short range to long range. The shorter range models have higher resolution, can actually resolve thunderstorms. Most private companies don't run their own models. They take the NWS models and forecasts and apply them specifically to customer needs. With the threat of extreme rainfall a day or two in advance, or even understanding the rainfall potential during the event, it's remarkable to me how poor the National Service models were at providing a 24 or 48-hour warning of this event. Probably other models didn't do much better. Part of the problem is that in Texas, the air that makes extreme rainfall enters the state from over the Gulf or northern Mexico, where observations are scarce or of lower quality. I've heard the key tip-off of heavy rain potential was the Thursday morning weather balloon launch from Del Rio. Why Del Rio in particular? Believe it or not, Del Rio is the only upper air station along the Texas border between El Paso and Brownsville, a distance of over 700 miles. It's worth considering whether additional observations along our border, what's coming into the state above ground level, would improve short-term forecasts of extreme rainfall and severe thunderstorms and tornadoes. I believe that they would. It's possible to do experiments with computer models to test the impact of different observing systems on the forecast, and then put in the systems that make the most sense. Among the technological options are profilers from the ground that measure moisture, temperature, and wind aloft, and having additional information from 3 or 4 sites may well have narrowed the area of flood risk considerably. Looking even more broadly, the Department of Atmospheric Sciences, my department, has been developing an idea to host a Texas Hazard Weather Interagency Coordination Center, which would help coordinate meteorologists from various agencies, including TDM and GWB, and other agencies on a longer time scale than the primary concern of TDM, which would be looking from 2 to 14 days and up to seasonal outlooks. We would look closely with TDM, and TDM would take over once emergencies was impending. So thank you for your attention. I'll be looking forward to answering your questions.
Thank you. Go ahead, sir.
Thank you for the opportunity to speak today. My name is John Schrader. I'm a professor of atmospheric science at Texas Tech University. I'm also the senior director of the National Wind Institute. My career has almost exclusively been focused on making measurements from the atmosphere using radars, lidars, tower-based measurements, and other devices. I'll be offering insights today on our West Texas Mezanet, as well as some forecasting insights and making some recommendations on how we might improve our monitoring systems for this particular type of event. Next slide, please. A good project within my institute that has a first-order impact on situational awareness of weather is the West Texas Mezanet. It's a network of 168 high-quality weather stations that are distributed over the western part of the state. It was initiated over 25 years ago and has slowly grown over the years outward from Lubbock in just about every direction. It's truly been woven into the fabric of West Texas. Our team handles almost every aspect of the related workflow. We deploy and maintain the stations. We create, manage the IT systems. We generate custom products. We disseminate the data. We integrate outputs onto our website, cell phone application, and data feeds. Next slide, please. The user community is really diverse. Agriculture, energy, transportation, but we have maintained a strong focus on weather. And one of our major partners is the National Weather Service. Our measurements directly feed into the NOAA via the National Mezanet program, but they also directly feed into the regional offices of the National Weather Service through our partnership in the local Weather Service office in Lubbock. Our